Okay, here. Now, actually, basically, you can see that this one only two, basically only two laws here. Why two laws? Okay, you see, the first one is the zero. Anything raised to power zero is equals to one. Okay, anything raised power zero is equals to one. And then another one, negative power, is when anything raised to the power of negative n, it will be just written as 1 over a to the power n. Okay, so take note here, the base a cannot be equals to 0, because when you have base a equals to 0, it's not defined. Same for this one also, a power 0. Okay, if you have a 0 here, 0 to the power 0 is undefined. It is not 0, it is not 1. Okay, it is just undefined. You can't tell exactly what the value is. So these are the values that you have to be careful when you want to define the 0 index and also the negative index. Now, actually, the next two here, actually the next two is actually the same like this one, like the second one. Okay, why you say that? You see, when this is power negative n, when this is power negative n, when it is a, so you're going to put it to be 1 over a. So now, if it's a over b, then you're going to invert the a over b, so it becomes b over a. Okay, so same for this one also. This is negative, right? So this is negative. If we want to change it to positive, then we will just invert the a over b becomes b over a, and that is the answer. Okay, take note, the common error people always have is they see there's a negative here, so they will bring the negative to the front and multiply. Okay, take note of all the indices questions, because we are actually doing all of them are base which are positive value. So for example, you have base 2, base 3, base 5, base 7, and so on, right? So they are all positive number. So when you do your sums, usually you don't have the negative in front. Unless the question started with something with negative, then you may have end up with negative. Otherwise, okay, you can see that all these base are all positive numbers. So you will never get something raised to power, a certain power will get you a negative number. It will never happen. Okay, you can see what 2 power 1, 2, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16. Now, all these you try to remember. Okay, you must at least remember until 2 to the power 7. Okay, for example, 3, you must at least remember until 3 to the power 5. Okay, 3 to the power 5 is 243. Okay, so all these, it's just like in primary school. I think P2 or P3, you start to learn the timetable, right? So 1 times 1, 2 times 1, 2, 2 times 2, 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, right? So here you are doing the power table also, not just timetable but power table. So you must at least know for 2 power 7, 3 power 4, or 5 power 4, 4 power 4. All these, the basic one you must know. I won't expect you to remember like 4 power 27, that kind, of course not lah. Okay, so the small numbers, if you can remember, so whenever you see the question, you straight away, oh, okay, if you see the number 27, you know, oh, it has something to do with 3. Okay, if you see the number 64, oh, you know that it has something to do with either 2 or 8 or 4. Okay, so that's the reason why we remember them lah. Okay, now what do we mean by zero index? Why got in zero index one? Okay, we just look at this example, 3 to the power 3 divided by 3 to the power 3. Now in arithmetic, if you want to do this 3 power 3 divided by 3 power 3, what you do is you will write the a cube to be a times a times a, 3 a's multiplied together. Same for the denominator, is the same thing, right? Then you're going to do cancellation, so you do by division, divide top by a, divide bottom by a, divide top by a, divide bottom by a, divide top by a, divide bottom by a, and so when you divide all by a, so you're going to get the answer 1, remember, not 0, so 1, because you're doing division, right? So it's equals to 1 here. Okay, but if you use in the indices form to do this question. So you have a power 3 divided by a power 3. That will be because they both have the same base. So when they both have the same base, when you want to divide them, you can just subtract the power. So you subtract the power, so you're going to get 3 subtract 3. So a raised to the power of 3 subtract 3. So 3 subtract 3 is equal to 0. So you see, we come up with a power 0. What exactly is a power 0? Before that, you don't know what is the you know the numbers when it's positive and so on, but you never come across something that is 0, right? So a power 0 actually is the same as this one because we are working it in different way. This is maybe the arithmetic way of listing out and then compare and simplify, right? And then this is using the indices form to solve the question, right? And then both of them should get you the same answer. Otherwise, when you do by this method, you get one answer. You do another method, you got different answer. Then something is wrong, right? So they should be the same. So when they are the same, that means we can conclude that a to the power 0 is just 1. Okay, it's just 1. So you can actually try other number, 7 power 7 divided by 7 power 7, etc., etc., etc. So you can try all the things. You will realize that, oh, as long as I have a power which is a 0 and the base is not a 0, then my answer is always a 1. So that is to say, every time when you see something with a power 0, you straight away no need to count what's the value. Okay, you straight away can say it is 1. Okay, but of course you must check that the base cannot be 0. When the base is 0, it's not defined. Okay, so that is 0 index. Okay, now what about negative indices? What about negative indices? Okay, how do we get negative indices? Look at this example. 5 to the power 3 divided by 5 to the power 7. So 5 power 3 divided by 5 power 7. So if you do the arithmetic way, you are going to list 3 5s on the numerator and then 7 5s on the denominator. Right? So by cancellation, by dividing by 5, dividing by 5, dividing by 5, so you're going to get 1 over 5 times 5 times 5 times 5, which is actually 1 over 5 power 4. Right? 1 over 5 power 4. Okay, if we look at the indices way of solving the question, if I have 5 power 3 divided by 5 power 7, because both of them have the same base. So when they have the same base, I can just subtract the power. Okay, so I subtract the power. So I say 3 minus 7 is the power. So 3 minus 7 is actually negative 4. So 5 power negative 4 is the way that you get, okay, when you are using the indices way to solve. And if you use the arithmetic way to solve, you get 1 over 5 power 4. And these two must be the same answer, right? Because it's the same question, so it must be the same answer. So if they are same answer, so can you see that when here we have 5 to the power of negative 5 raised to the power of negative power, it actually just means the number which is 5 and the 4, you take away the negative but put it into the reciprocal. Okay, so you see, when a raised to the power of negative n, it is just 1 over a to the power n. Okay, so when you have a number raised to a negative power, this is just equal to 1 divided by the number raised to the power that is made positive. That means we remove the negative, so it's positive. Okay, so that's how the 0 and how the negative indices came about. Okay, so we look at some examples. Okay, like here I have base 3, base 3, base 3. This is index form, index form, index form. So these two are multiplied together and then divide. Okay, so how do I do the question? So one way to do the question is you can do all together. That means when they are multiplied together, you add up the powers. When they are subtracted, you subtract away the power. Okay, so these two added, this one subtracted. So therefore, you have negative 6 plus 9 plus 5, because negative minus negative 5, it will be plus 5. So now your answer will be 3 to the power of 8. So you see this one here, you have all of them same base. So if you want to do everything together, this is how you do it. Okay, for example, like this question, okay, similar to this one. Okay, they have all the same base, but these two multiply together, these two multiply, then the whole thing divide, right? So you can do this way. You can do the numerator. If you find that, wow, there are too many later I cannot handle properly. So if you prefer to say, okay, I settle the numerator first, then I settle the denominator. Okay, then later then I combine. Okay, so if you multiply the numerator together, the base are the same, so you have -4 plus 3, you add up the powers, and then these two also, the base the same, so you add up the power. So you now have 7 to the power of -1 for the numerator, and then the denominator is 7 to the power of 6. Okay, so now you are dividing these two, so you subtract. So -1 subtract 6. Okay, so -1 subtract 6 is -7. And usually the question always wants you to write your answer in positive index form. Okay, so this is going to be the answer. That means you will write it into 1 over 7 to the power of 7. Okay, remember previously, the previous slide says that when you have a negative power, you just take 1 over, okay, and then remove away the negative sign here, 7 to the power of 7. Okay, some more example. Okay, so just now we use numbers. You find that, oh, numbers very easy to handle. Okay, what about if you are having like letters? Okay, just now was arithmetic. Now you go on to algebraic way of doing. Okay, so you see that here we have something square. This is m squared. This is k. This is k. Okay, so we know that m is by itself. K and k here can simplify. But before we simplify, we first have to remove the brackets first, right? Bottomless, okay, brackets first. Okay, so we remove the bracket. But take note, many people will give me the answer as m square here, which is wrong because you always imagine things. Okay, there is no bracket here, so when there's no bracket here, it just means the negative of m times n. The negative of m times n. It is not negative m times negative n. So you take note of that. Okay, so here when we remove the brackets, okay, so you see when we remove the brackets, see this is a negative sign, right? So this one you can treat it like a -1 multiplied to the m square. So when -1 raised to the power of an odd number, which is 3, so you have -1 times -1 times -1, your answer is going to be negative. So the whole question here, your final answer later is going to be a negative, because why? These two parts don't have any more negative already, so there's only one negative here. Okay, so m squared raised to the power 3, so it will be m of 2 times 3, which is 6. Okay, so you can also consider this also like ab raised to the power 3, it will be a power 3, b power 3. Okay, so you have this as the answer. Then the denominator is k, so k also raised to the power 3, so k3. So now it's simpler already because the bracket is removed. Then next is we're going to combine the k with the k and then leave the m alone. Okay, so leave the m alone and then the k combine. Okay, so k you can put it as k power -7, then -3 because you are doing division, so division is subtract. Okay, and so you have this as k power -10. Okay, so usually whenever the indices have a negative power, you are expected to change it into positive. So you're going to write the k to the power 10 at the denominator. Okay, at the denominator, like this. Okay, so from this one, we simplify it to this, and cannot simplify anymore because m and k are not the same, so you can't combine. Okay, next one. Got P, got Q, got brackets, got powers, got positive, got negative, right? So usually for this kind of question, okay, we will always, okay, there are two ways to do the question. One way is you consider, you take this whole thing as like a times b to the power of -3. So you first remove the brackets. Okay, you first remove the brackets. Same for this one, you remove brackets. Another way to consider the question is, you see that this is -3. So we don't like negative. So how do we change it to positive? So if you want to change it to positive, that means the whole thing here, we are going to put it in the denominator. And then the whole thing in the denominator, you're going to put it up to the numerator. Okay, so that's another way of doing. Okay, but this answer here, it shows that they remove the bracket first. Okay, they remove the bracket. So when you have p to the power of negative 3 and then q to the power of negative 3 times negative 2 times negative 3, so that would be q to the power 6. Okay, for the denominator, you also have p to the power 3 raised to the power of negative 1. So p to the power of negative 3. Okay, because the powers multiply together when you are having the power law. Okay, power law. And then next one is q raised to the power of negative 6, then raised to the power of negative 1. So you are getting q to the power of 6. Actually, when you reach this step, you can straight away say the answer is 1 already. Why is it that you can say the answer is 1? It's because you can see that this is p power negative 3. This is also p power negative 3. So actually you can cancel them straight away. And then the q also Q6 and Q6, so you actually can cancel them. Okay, but here the answer they show step by step lah. Okay, so they combine the P, combine the Q, then the P gets 0, Q power 0 also. So when you have power 0, you actually get 1, and so 1 times 1 equals 1. Okay, so this one is a very detailed way of working. Okay, another one. Okay, negative indices. Okay, here we have this whole thing, wow, got P, got Q, got R, so 3 different letters, right? So again, if we want to remove the first thing that we do most likely would be remove of brackets. You can also choose to make this whole thing to be at the denominator so that the power of 4 becomes positive 4. Okay, and then this whole thing here, also because it's negative 4, you can also bring the whole thing up so that it becomes positive 4. For me personally, I prefer to use the positive powers. So because when you remove also easier, because everything positive is always easier to handle than negative, some positive. Okay, but this one is the answer from a book lah. Okay, so what they do is they do this one. Like they go and remove the brackets first. They remove the brackets. So you can see P is by itself, so P1. Then P raised to the power of negative 4, so P power negative 4. Q raised to the power of 6 and negative 4, so will be Q negative 24. Then the next one, P raised to the power 5, and then Q raised to the power of 2 times 5, which is 10. Then the denominator, P raised to the power 2, Q raised to the power 2. And then the next one is P raised to the power of negative 4, Q raised to the power of negative 12, R raised to the power of negative 4. So the first step that it was done was by removal of all the brackets. So you see a lot of negative. For me personally, I would try to shift all the negative to become positive so that it's easier to do. Okay, so that's my personal preference. So up to you if you find that it is easy to handle this way, by all means. Okay, so here the P combined with P, so you have one P, another P, another P. So put all the P's together. Then the denominator also put the P's together, put the Q's together. Okay, and then you get P, the Q, and then the R. Okay, then after you getting simplified it already, then you can see that here they include the R0 here so that they make it when later they do the subtraction, you see. So now you have this P combined with the P, because this is division, so you subtract. And then this one also divide means subtract. And then the next one is nothing, initially was nothing there, so it was 1 there, so they put the 1 to be R power 0. So therefore you have the R power 0 minus negative 4. Okay, so you have this as the answer, and this one don't stop here. Okay, you got to change it into the Q to be a positive power. Okay,